Nice to meet you all here. It's a pleasure to meet you at such a lovely place, at a school. Very nice place to learn something new, right? We'll see a bit into how Neutron leverages interchain things as one of its core features. So I think we can start. I'm Sergei. I'm a developer in Neutron. Also, I have Thomas, our marketing lead, as my support. Let me remind you what Neutron is once again. It's a recently launched blockchain with permissionless smart contracts support. It means that you can deploy any smart contract you want on our blockchain. Neutron makes use of IBC, inter-blockchain communication, interchain queries, and interchain accounts as dedicated modules in this in the blockchain. Also, Neutron is the first interchain secured network. It means that it's secured by Cosmos Hub, which makes it the most secure Cosmos smart contracts blockchain. What you're gonna do today? Today we're going to deploy smart contract on Neutron, which utilizes interchain queries, only interchain queries, no interchain accounts today. I'm sorry, no time for it. We are also going to set up an iSecure layer, our Neutron own app, which periodically processes interchain queries and evaluate the results of the flow. What we need before we start? I need you all guys to have Golang of version 1.20 installed because it's required by the applications we're going to use at the workshop. Also, I think you all have Git installed, and GQ also sometimes comes from the box, out of the box on some operation systems. So, is there anyone who doesn't meet these requirements at the moment? Cool. Excuse me, ma'am, you raised your hand. Is everything okay? Yep. You don't. Could you please? Okay, so to ease the flow, I prepared a GitHub repository. You can find it here. Could you please visit this website? It's my GitHub account, and find there NNW helper and NW for Neutron, Nebular Neutron workshop. There is a file, a README file, where I put everything which we will use today. So, like, you can just copy paste commands to avoid the routine typing. Let me know when you are okay. Don't let me know. I'll just give a couple of minutes for you to get into this to make it done. So the repo looks like this. There is a README file which contains almost anything anything you need. There is also numbers that I will refer to, so you understand what I need from you. And also, I have a request. Let's make the workshop super, I don't know, casual maybe. Don't hesitate to interrupt me. Ask me anything, anytime, so I can help you. I think it would be nice to have here a mic, which we will give to the speakers among the audience. Can we have it? Tom, can you help me, please? In case there is a question from the audience, can we have a mic, another mic? Cool. So I think we can proceed. What? You can find QR codes to connect to Wi-Fi, to local Wi-Fi here on your desks. Could you please speak a bit louder? 1.20 or above, yeah. So the steps we should go through at this point are showed at the screen. So if you all have Golang Git and GQ installed, and the next point would be to allocate a workspace folder for this workshop. For example, you can create a project/nnv NLW folder in your home directory and store everything that we will need for the workshop in this folder. What we will need exactly are these helper repo cloned and ICQ relayer and Neutron core cloned. I have links for them to them in the README file in the NW helper repo at numbers 2 and 3. So once you have the NLW helper, you can proceed to these two sections and clone the Neutron core relayer and Neutron core projects to the workspace folder we prepared at this point. You also will have to run make install from Neutron, and it can take some time, so let's wait a bit until everyone is set up. Can I help you? Can I help someone with something? You just can raise your hand, and I will approach you and see into your problem. Let's make a little check. Could you please raise your hand if you have done everything that is described on the list? Who is half ready? So, friends, please don't hesitate to ask me if you need any help. I can see we are a bit blocked with something here. We need to install all this in order to have a practice workshop. Well, actually, you can just watch the screen, because I'll be doing the same as everyone here. So if you don't want to put your hands on the practice part, so you can just look at the screen and see what happens. I'll describe each process, each step quite detailed, so it's comprehensive for everyone. Let's make another check among us. Who's ready? Please raise your hands. Yep. Cool. Who's almost ready? So, okay, I'll proceed to the next step. It will be a bit of theory here, so we understand what happens in detail. So you can finish until I'm talking. First thing we will take a look at is the smart contract that uses the interchain queries. But before we start, I'd like to dive a bit into how smart contracts work and how they are structured. The most general and the most understandable part of a smart contract from the first time is the interface of the smart contract. Interface of the smart contract is the number of entry points it has. First of them is instantiate. It deploys an instance of a smart contracts to the chain with a given configuration. Execute, which performs commands to the smart contract, modifying its state and the blockchain state. Therefore, queries are read-only messages to smart contract. Sudo is privileged access to a contract from a module. It will be used by the interchain queries module of Neutron. And reply for sub-messages handling. Also, there is a migrate in entry point, but we don't need it because it's out of all the scope. Please raise your hands who has experience in working with smart contracts in Cosmos. So a bit of experience. Okay, that's cool. Let's take a look at the contract I've prepared. As I said, there is a number of entry points, and these entry points are accessed by corresponding messages. The first message is for the instantiate entry point is instantiate message. For the contract I've prepared, there is an instantiate message as well. But before I begin, let me walk you through the idea of the smart contract. Smart contract is called Robinhood Manager. Just for fun, I don't know. Robinhood Manager collects information, gathers information about how rich addresses, accounts on a remote chain are. So he decides whether an address, whether an account or owner of the address is rich based on a rich line, which is defined in the contract's configuration. If it's rich, if the address has more funds than the rich line, contract declares this address as rich. So Robinhood himself can deal with them. Also, there are the poor who receive the money from the Robinhood, but it doesn't matter because Robinhood Manager, the only thing it does is he collects a list of the poor and the rich. So the instantiate message, the initial configuration of the smart contract, is the rich line. We set it. The denom in our example, it will be uAtom. Frequency, how often the manager evaluates one's richness. In other words, it's the update period of the interchain query we'll be using. And the connection ID, it's needed because interchain queries use IBC Lite client to prove the key value results it gets from the remote chain. There are execute message there is execute message, only one. Keep an eye on to tell the Robinhood contract manager to spy on something, on someone's pockets, and to evaluate its richness time to time. There are also a number of query messages. Objects, the list of all the people manager looks after, the rich, the poor, and the unconfig. What happens inside? Nothing interesting in the instantiate message. It just sets the configuration for the contract, and that's all. In execute messages, we can see only keep an eye on, which basically registers an interchain query on the Neutron chain, which will be then handled by interchain query relayer time to time. And that's all, basically, if avoid details. There are also queries, as we saw, objects, rich, poor, and config. They are just getters of contract's state. We'll get back to them later once instantiated the contract. And also there is a pseudo entry point, as you remember, pseudo key-value query result. It's the pseudo message sent by the interchain queries module of Neutron to smart contracts once key-value query result is submitted to Neutron chain by interchain query relayer. In short, Neutron chain passes result of interchain query to the contract directly, so contract can handle the result of the interchain query. In this case, for the Robinhood contract manager, when a result of an interchain query reaches the contract, it's the balance of the address on the remote chain. So when we get the balance, we simply evaluate it. If it's more than the reach line, we save the address as reach. If it's less or equal, no, if it's less only, the address is poor, and we save it in the poor list. Also, there is a reply handler, which I don't want to get into the details. If you are interested in how it works at all in details, these contracts, the source code of the contract is stored in the helper repository that you cloned, so you will have opportunity to read the source code later. So let's start with deploying smart contracts. But before we do so, there is also one another step that we need to do, is configuration of the default values for Neutron core. As you might know, there is a number of configurable values in the CLI of a binary of a chain. For example, you can set chain ID, keyring, backend, output, node, which you are talking to, and broadcast mode. So in order to avoid typing these values over and over again, you can use the neutron dconfig command, which will set these values as default values for your command. If we take a look at it, there are these default values. So if you just run these 5 commands, the same will be applied to you, and you won't have to define the node, the output, the keyring, backend, etc., over and over again. We need to make a key pair before we instantiate a contract, which we will use in our case. If we run this command at number 6, it will create us a new address under the name NNW wallet. We will use this wallet throughout the whole workshop. You'll need it. The next thing to do is to use the Neutron faucet to have some testnet neutrons. We'll be deploying the contract on Neutron testnet, and we will run interchain queries to the provider blockchain. It's the dedicated Gaia blockchain that is used in testnet as a provider chain for other consumer chains. In order to use the faucet, we have to talk to. We need to contact the dedicated channels in Telegram or Discord. Use these QR codes to get to the. Oh, now I realize that Telegram doesn't work here. This is quite funny. So the Discord option is one that you need. You can either scan the QR code to get to the Discord application from your phone, or you can use the helper file. There is also a Discord section where there is a link and there is a instruction how to get the neutrons. So if I click here, Discord will be opened. Then I should go to the very bottom. There is the faucet. Sometimes there could be a problem because testnets are a bit unstable. So you probably should first probably type your command twice here, and if it will work eventually. So I need to copy this command, which I would put into Neutron faucet, and substitute the address placeholder with the key I've created, with the address I've got. If you have run these commands, then the query to check the balance of your account will be as simple as possible. It's neutron d q bank balances and your address. Now I can see that I've got 3 neutrons. That will be enough for the workshop. But if you run out of neutrons for some reason, you can ask the faucet once again. It will give you more neutrons. So let's have a little pause until all of you can do this. A couple of minutes. The next step will be instantiating of the contract of the Robinhood manager. We'll instantiate it, we'll check out that it works, we'll see its configuration, its default state, and then we'll proceed to the interchain queries relayer. If you now go to the NLW helper repo, you will see there is a one second. It should have. No, we don't need it. The contract that we were talking about, the Robinhood Manager, needs to be built. It was needed to be built, but I've already built it into a .wasm file. It's the binary that can be uploaded to the Neutron chain to then instantiate it in the future. There is another command to instantiate the contract under number 8. This command can be copied and pasted into the terminal. But before we do so, let's take a look at the instantiate message. There is number 100,220, which is the code ID of the binary I've uploaded to the chain. It's the binary ID of the source code of the contract. So we are instantiating an instance of contract with this number using these values. But before we do so, we need to make a little hack. We need to substitute this with 42. That's the correct connection ID we will use. So what we should do is to copy this command and put here in the command line. We define the reach line as 1 million of U atoms. In other words, 1 atom. Frequency of updates for the interchain query that is inside the contract, that is used inside the contracts, is 60 blocks. And the connection ID and the respective light client, light IBC client, is defined by this field. So if we run it and say yes, we'll have to beat. Yeah, this kind of error was the error I was talking about when I said that testnet is a bit unstable. So we can give it another shot until it works. When it works, finally, we'll see a large JSON output. Interesting. Sorry? Yeah, I see. Sometimes it works from the very first try. Excuse me? Oh, maybe, but it's admin Albert. Let's check. I wonder if. So it worked for you, right? Yes, but not on the Wi-Fi. Not on the Wi-Fi. If you have troubles with running this query, try to use probably your hotspots. Oh, maybe there is a typo in the configuration. There is no typo. I wonder why it refuses my my calls. Queries work, transactions don't. Sorry? Yeah, probably. Yeah, let's do so. This one? Could you show me the password or type it? Do everyone have the same problem that I have, like this connection reset by peer or connection refused? No, it didn't work. Right? Is it correct? Maybe you disabled joining for others. Hmm? Yeah, let's do so. Can I use yours? Oh, Mori. I see. Can you type the password? Yep, it's connected. Let's make it another try. Thank you. What? I see. I should probably make another request. I'm sure it worked, but this error. Nope, not yet. Haven't came to me yet. This wallet, Neutron D, Q, bank, balances. Yeah, I have some neutrons, so I have to be able to do so. Ah, I see. Maybe it's too much for me. Yeah, finally, I did it. There is a huge response from the chain that tells me with code 0 that my transaction worked. Here, among the raw log, I can see contract address. Actually, there is a more human readable part in logs and events. there is type instantiate event with attributes contract address. This contract address is the address of the contract I just created. Now I can do the following. I can take a query from the very bottom of the README file with objects and see and substitute the address with the address I've just got. If I copy paste it and replace the address with my own, I will see that there is no objects yet because I haven't added any. I can also make a config query to the contract that will show me the current configuration of the contract. It's the owner, my wallet, rich line that we set, asset denom that we set, connection ID and frequency. That's fine. The next step is to register interchain queries on the contract. But before we do so, we need to run a relayer that will help us in this task. So there is a huge diagram, I know, right? But we need to get into this in order to understand what the Neutron ICQ relayer is and how it works. So basically, it's not as hard as it looks like. There is Cosmos Hub, there is interchain queries relayer, and Neutron chain. Neutron chain has interchain queries module and WASM module. In the Neutron chain interchain queries module, there is an interchain query, a structure that is created in the module each time a contract registers an interchain query. There is a type. For this case, it will be key value, meaning we will read the remote chain storage. There is owner, the contract that created it. And also there are keys that define what exactly we want to read from the remote chain. Path will be bank because we are querying for bank module for balances of accounts on the remote chain, and key with the address on the remote chain and denom. The owner is the contract as it is showed with this line, and the key, one of the parts of the key is the address on the remote chain. Interchain query relayer has a large configuration, but the most interesting configuration parameters at this point are Neutron node is the node that has neutron state on it. Target chain node, the same for the target chain. In our case, it will be kind of Cosmos Hub. And registry addresses. Registry addresses is the list of smart contracts which interchain queries the interchain query relayer will work on. In other words, interchain query relayer takes only interchain queries from these addresses from the Neutron module to submit only them, to work only with them. So the flow is, first, interchain query layer gets interchain query details from the Neutron. Then it reads the target chain storage, getting the values that are defined in the interchain query itself. And then it passes query result to the contract, so contract can handle them. The next step will be setting up the interchain query layer. As you already done here in the point 2, I think you should already have the Neutron query layer. Let me do the same. I may git clone. Could not. Permission denied. What? Okay, I have my own already cloned query layer. Did anyone here had the same problem? The same problem? Mike, please. It's turned off.
It's TCP, some weird thing.
Probably.
But it was.
I can. Wait. So did anyone have the same problem with cloning the repository? Okay, I see. Never mind. I have it on my laptop, so it doesn't matter. What we need now is to configure the iSecure layer. It is described in the iSecure layer section under number 30. First, we need to do is copy the .env file from here. It is here, right here. It's the configuration file for the Interchain query layer. I've already populated it with the values needed for the workshop. So simply copy this file into the Neutron query layer repository. Here in the root of the Neutron query layer, there is an env example and env example def, etc. These env files should be exactly here. So what I do is copy the .env right here and see whether it worked. Yes, it's already filled with the values we need. What we need here is the addresses of the nodes of the Neutron chain and the target chain. There is also key name that will be used for signing the transactions from behalf of the Neutron query layer, and connection ID. These all should match what we need right now. Other thing that we need here is to put our contract address into the relayer registry address. It's here. We need to take our address of the contract that we just created and put it in this very value. It should look like this, but instead of my address, there should be your address. The next thing is to run the relayer. But until we do so, let me know if I can help you about Interchain query relayer at this point. Let's have a couple of minutes to wait until everyone is set up. We haven't registered any Interchain queries yet on behalf of the smart contract that we instantiated. We just need to set up the relayer at this point. And then we will register the queries, and then we will run the relayer so it can, so to say, relay the Interchain query results right to the contract. What we will do what the Robinhood manager do is looking after Alice and Bob accounts at the provider network. These are the addresses of Alice and Bob. You can see them near the 12, number 12 in the README document of the helper repo. But to do so, we need to register respective interchain queries for them. To do so, you remember, we have an keep an eye on execute message in our contract that will register interchain queries messages, interchain queries. If we copy these and run it, the contract will register interchain query. But before doing so, we need to fund the contract with some neutrons, because interchain query registration on Neutron is not free, but it takes 1 neutron as deposit from the caller because it affects state of the chain, and it shouldn't be free. Otherwise, someone can register tons of interchain query messages for a little money and pollute the state of the chain. So it's kind of fee for using these, temporary fee for using these mechanism of Neutron. So there is also a helper under the section share Neutron with the contract to pay ICQ registration deposit under number 10. You just take this query and run it. It will send from your NL and NW wallet 2 neutrons to the contract. So the contract can pay deposit for 2 interchain queries registered. You can probably run out of funds here. If you do so, visit the Discord once again to get some more tokens on your NLW wallet. So it suffices the call. So transaction went good. If I check the contract balance, it will be 10 neutrons. Why so? I asked only for 2. Okay, doesn't matter. Probably someone made me a present. So, I see. Or I don't. Huh. Yep. There should have been an address of your contract. Sorry for this. You should put your contract address here, because we need to fund our contract with these funds. So we will need to make another request to the faucet, because probably there is no money left on our accounts. That would make sense to save our contract address for a while on some buffer, so we have easy access to it. Nice. This is my brand new smart contract that hasn't yet been mutated, so I can send it money. Don't remember to put your contract's address here after the send command. Sometimes it writes that your transaction timed out to be included in a block, but don't Don't trust it like this, because sometimes it works. Okay, but not in this case. Need to make transaction send once again. Yep, it worked now. And actually there is 4 neutrons. As I said, sometimes it works, sometimes it doesn't. Now it worked 2 times, but okay. More better than less. Now when our contract has enough neutrons to pay for deposit, we can actually register interchain queries. To do so, find the register interchain query section, number 20, number 12, sorry, still never know, and run this query. Once again, it makes the Robinhood contract manager keep an eye on the address that we provide as the parameter. One of them is Alice account, which is poor. The other one is the Bob's account, which is rich. Why they are poor or rich? Because I've already sent them some funds, so they are poor or rich, just to ease the flow. So let's make it. Let's create an interchain query for poor Alice using our contract. We need to make the same. We need to substitute the placeholder with our contract in order to execute a message on this very contract, on our contract. And we pass such a message to the execute, to such a payload to the execute as an execute message to our contract. When we execute it, we'll have not enough funds message. How long? Why? Maybe I've run out of funds once again. Faucet, help me once again. That's good to have a faucet, right? It can give you money for free, so you can operate on your blockchain. Don't be thirsty. I see. How many neutrons do I have on my account? 0. Okay. Is it possible? Oh, I have a life hack. We have an ordinary faucet for the testnet, which is more strict. I mean, it provides you with neutrons with a bigger time span between your requests, but still it can help you out in such a case. I just requested money from it, and now I should have, 2 neutrons. Cool. If you run out of money, you can use the ordinary testnet faucet in the peon faucet section of the Neutron Discord. And later, in like 6 minutes, I'll be able to do the same using the dedicated faucet. So I have 2 neutrons. It should be suffice to register an interchain query that I'm so eager to register. Let's check it out. It all seemed right for me. Let's call it. Yeah, of course. timed out to be included in a block. But as I said, don't trust it just like this. Let's make a query that will help us to distinguish whether it worked. If I query Neutron, if I query the contract with objects message, yeah, time went a bit, and we have our contract in the contract state. If we look here, the contract is the poor Alice contract that was registered by this query. It's only the contract state for now. But we can also make sure it worked by running okay, it doesn't really matter because it's too much of details for now. What we need now is to register another interchain query for Bob. We do the same. We take the Bob's address this time. Whoa, cool, so fast this time. Yeah, and now we should see two objects. Yeah, in our contract state. These are addresses of Bob and Alice. But still, if we ask for the poor and for the rich, we see nothing. Why? Because we only registered our interchain queries, but we haven't yet run the interchain query relayer to actually relay the queries, to get the values from remote chain and to submit them to our network. To do so, we need to here. To run the relayer, we need to get back to the ICQ relayer section under number 30 and see the third point here, how actually to run the relayer. We need to run this command, just copy it and paste it into the Neutron query relayer root repo. But before I do so, I need to check out the values are correct. Values are correct. So what I do is I run the relayer. As we can see here in the logs of the relayer, here are some instantiating logs that we don't really care of. But here we have two log lines about the interchain queries we have. We have query IDs 42 and 44. These are interchain queries. These are IDs of interchain queries that we have registered just before. And we can see message proof for query submitted successfully. What it means? It means that interchain query relayer got these two queries from the Neutron chain, got the details about them, the keys which have to be read from the remote chain. It went to the remote chain, contacted with it, queried the respective keys from the storage of the remote chain, and then it submitted the results to the Neutron chain and to the contract itself, so the contract can handle it. Remember how contract handles the query results. It decides whether the address is poor or rich. So one submission is enough. I can now shut down the relayer and see the state of the contract once again. There are still two objects, one for Alice, which is supposed to be poor, and one for Bob, which is supposed to be rich. YMC8 is Alice, the poor one. Now if we query the poor, we should see the Alice here and the height of the query submission. If we query for the rich, we will see the Bob here. And this is how this whole stuff works. Once again, we have created interchain queries using contract. We have defined handler for interchain query results. And we have run relayer, which passed the interchain query results to the contract, so it can handle it. What else? I think this is it on the practice part. We have some time for a questions and answers session, and also I have some info for you. As a teacher, I suppose I should give you some homework. So if you're eager to know more about Neutron, you can reach our docs website, where there is a lot of information that I couldn't cover during the workshop. I covered only one of the features of Neutron, and it's a tiny feature compared to all the work that we've done over the over the Neutron. There are also interchain transactions. It's a module, it's a feature of Neutron that makes it possible for a contract deployed on Neutron chain to control addresses on the remote chain and to execute messages on the remote chain on behalf of the interchain account. There is also IBC transfer module with pseudo handling. It means that contract can make use of IBC transfers, but not in ordinary way, just transfer and forget it, but also process the transfer that it's done by the same pseudo handling of the messages, of the acknowledgements of the IBC transfers. There is also Neutron DAO. It's a big separate world in Neutron ecosystem, in Neutron blockchain, that is very much comprehensive, very much complicated, but still we have docs that describe it very well. We have Neutron DAO, we have sub-DAOs that are smoothly controlled by the main DAO. There is also a section about ICQ relayer if you want to learn more about it. Also, there is a big topic about tokenomics of Neutron. It's also something that we've been working on very hard and very long, and much more. At the end of my presentation, and before we proceed to the questions and answer section, I want you guys to make fun of verifiable credentials for Neutron attendees made with partnership with Creds. You can scan this QR code and claim a verifiable proof that you've been at this workshop and done all this stuff. Thank you. So, any questions to me or to my colleagues, Spade and Tom? No questions then. So, if you have actually some questions, you can come to me after the workshop. I'll be happy to answer your questions anyway.
No, it's on. Oh, I have a question actually. Okay. What are the kind of like most obvious use cases that you can think of for interchain queries? Like, as a developer who wants to build an application, and like, how can I use that actually?
Well, if you are up to make an interchain protocol on the Cosmos ecosystem, you can gather some information on remote chains and process it on the Neutron chain. So if you deploy a contract on Neutron that wants to know some information like delegations amount of someone or balances or anything else, literally you can query anything from remote chain state. You can handle it in any way you need on the Neutron chain and decide how to act further.
Thank you.
Sergei, thank you so much again for hosting this. Thanks, guys.